Reason for choosing the material as tin or alloy of tin and copper to make fuse wire is that these materials have a melting point lower than the normal connecting wires and devices. So that's what. Okay. And while buying an electric device or appliance such as bulbs, tubes, CFLs, fuses, MCBs, we should check that there is a ISI mark. ISI mark of the Bureau of Indian Standards. This you have to check. If ISI mark is there means that is of good quality. Okay. Then there is something called energy leveling system. Like you will see like 5-star rating, 4-star rating, 3-star rating we say. Okay. So that energy labeling system for refrigerators, tubular fluorescent lamps and air conditioners in India has been launched by the Bureau of Energy Efficiency. Okay, by the Bureau of Energy Efficiency. This bureau is responsible for the improvement of energy efficiency through various regulatory and proportional instruments. Okay. Commonly, energy labeling is known as star rating. Energy labeling is known as star rating. The BE label displayed on a product indicates its energy efficiency. Okay, like its rating will be from 1 to 5. An indicator on the semicircular top shows the star rating of the product that it has in. So you have to suggest your family members, or when you go for a shopping, if your parents are buying any new electrical appliance, you have to tell them that Papa ISI mark, whatever their ISI mark appliances you buy. Okay, how to suggest it. And there is also something called energy labeling system. So if more is the star rating, the more is the less is the energy consumed and more energy efficient it is. Okay. Next, checkpoint 2. Please tell me the answer, first one. What is the answer, first one?
Sir, heating.
Yes, very good. And then second one, coiled wire of a bulb is called. It's
Sir, filament.
okay. Yeah. Materials of low dash produce a small amount of heat.
Sir, resistance.
Yes, very good. The element of an electric device is made of.
Sir, coiled wire.
Yes, coil wire. All the electrical appliances have a built-in
Sir,
safety tool.
fuse.
Yes,
Sir, fuse.
yes, very good. Fuse.
Sir, fuse.
Yes.
Sir, fuse.
So till now we have learned one of the effect of electricity, that is heating effect. Okay. In the next one, next effect of electric current is magnetic effect. Okay. So whenever you pass the electricity, there is a magnetic effect. So what is it? Actually, there is one scientist. Okay. So like when you take any battery and it is connected with some wires and resistors, switch key, okay, and you allow the current to flow through by closing the key, and then at nearby, when you keep a magnetic compass, it will show some deflection, left or right. It will move left or right, the deflection. So that indicates there is a magnetic effect. Whenever a current is passed through a circuit, there is also magnetic field is generated surrounding to it. This has been proved. Actually, accidentally, it was observed by Oersted. Oersted is the scientist name. Okay, Oersted, Hans Christian Oersted. He observed that current carrying conductors produces magnetic field. Okay. When you bring any electric so this experiment we have done last year. Okay, we just check it to test the magnetic effect of electric circuit. The magnetic deflection is zero. When you bring any electric circuit near to it, you can see some deflections in it. Any complete circuit. Once again, you see the magnetic deflection is zero. When you bring the electric circuit near to it, what is happening? So there is a deflection. So that is what. So that is what.
And sir, if we bring a magnet in front of it, it will not work.
Yeah, we have done that magnetic compass near to like we brought magnet near to magnetic compass so that it will not work it as a navigator.
Yes,
that you have done. Still, that video is also there with you. Whatever we have seen now, that is Oersted experiment. What you can also do this activity. So that is what this activity actually. So to show the magnetic behavior of a conducting wire on passing the electric current. Whatever we have shown, that is only this activity. Okay. So yeah, here only it is given Oersted. The magnetic effect of electricity was first studied by Danish chemist and physicist Hans Christian Oersted. He laid the foundation of electromagnetism by showing that there is a distinct connection between electricity and magnetism. So based on his experiment only, there is a new science, electromagnetism. The combined effect of electricity and magnetism was came into picture. In that particular science, electromagnetism, we learn the relation between electricity and magnetism and effects and what are the application like electric motor, electric generator, many applications are there. Okay, that we will understand in class 10. So here they have given some new words. Magnetic field, area around a temporary or permanent magnet where magnetic force is effective is called magnetic field. If you see, like if you bring any iron nail near to the magnet and if you keep that iron nail only in certain region, then only it gets attracted. Otherwise, it will not get attracted. So that particular area where the magnetic force can be into effect is called magnetic field. Okay. Solenoid, a cylindrical coil of wire acting as a magnet when carrying electric current. Solenoid is a one kind of some small component, like it is a cylindrical coil. I'll show you the diagram. The cylindrical coil will be. This is what solenoid. The cylindrical coil, the current carrying solenoid coil is used to magnetize steel rod inside it. Like inside the, it is just there will be a one cylindrical rod and around it there will be copper turns. Wires are turned. Okay, and that gives you like a coil of many circular turns of insulated copper wire wrapped closely in the shape of a cylindrical cylinder is called a solenoid. Okay, so, so a cylindrical coil of wire acting as a magnet and current is flown to it. That is called solenoid. And that is only we call it as electromagnet. Whenever you supply electricity, it behaves like a magnet. That is called electromagnet. And when you stop flowing the electricity, then it stop behaving like a magnet. So that's why this electromagnet or solenoid is a temporary magnet. Temporary magnet. Okay.